Welcome to this small tutorial about how to put the NES emulator onto the ESP32 microcontroller, which you can see here. This one is a SparkFun ESP32 thing, which I bought obviously from SparkFun, and it has the ESP32 microcontroller unit right at the center of it, next to the flash chip, and this is the basic setup for an ESP32 device. What you see here is a screenshot from my previous video, which you can view here. As you can see, I already showed you that this is a SparkFun ESP32 thing board, but there is this LCD module which you can be familiar with, and if you're not, then I will show you where you can find it later on this video. And also in this hardware setup is pretty much obvious. There you can see the breadboard at the background and all these wires which connect directly from board to board. I'm using the SparkFun module here, but this can be done with all ESP32 based boards. I like this one because it is narrow and I can put it in my breadboard, and it's also breadboard compatible, and it has an integrated FTDI chip right here, so I can plug it directly to USB on my computer. The hardware setup is really just this, so I won't waste any more words on this. You can figure it out, and later on I will show you which GPIO pins you should use with the LCD module. And before I start, you may want to watch the original video made by the guy who ported the NoFrendo emulator to the ESP32. There he explains why he did it. Let's start up with this. As you can see, I have set up an empty directory, well, almost empty, because I have the Mario NES image, which I won't show you how to download from anywhere. This is simply just for testing. And yes, this is empty here, and all we need to do is gather all the things for compilation, development in this directory, and then we can upload the firmware onto our module and see it work. Okay, where to begin? As you can see, I am using the Git, and it is a good place to start because they always update the framework, and I've just searched for the ESP IDF, which stands for Expressive IoT Development Framework. This is the official development framework for the ESP32. If you go down here, you can also see the Arduino core for ESP32. If you're not that advanced in using FreeRTOS and the ESP IDF, then I may suggest using the Arduino core, but with the IoT development framework you can do much more things, like this one here. So we will go into the ESP IDF, and here is the source code. I will scroll down, and this is just a short readme, and here you can see there are setup guides for different kinds of operating systems, and because I'm using Linux here, I will show you how to do it in Linux. I'm sorry for other guys, maybe I will try to do a Windows guide also. I don't know what my wife will tell me about that one, because she has a Windows machine. For now, let's start with Linux. And as you can see, it's a pretty much detailed description about what you should do. First, you have step 0, which means that you will need some packages in order to compile and download and everything else you will need to make this work. And what I am scrolling here is the one that should be used with Ubuntu and I don't know, Debian. I'm sorry if I didn't pronounce it correctly. I am using Ubuntu Linux, so I use this one, and of course for me this won't do anything because I've already done this. Yes, there is nothing to download, but you should do it in order to have everything set up for you. Of course, Arch Linux users should use this one here. I won't use it because I am on Ubuntu. And we can go to step 1. Download the binary toolchain for the ESP32. And this is used to compile and build the source code. And because I'm using a 64-bit Linux machine, I will use this one. And here they tell me that I should create a directory for the ESP, go into that, and okay, they didn't tell you that the download will come here, but you need to do something like this. I will do a more easy way. First, just get this gz, and this will download me the binary toolchain, everything needed to compile the source code for us. And in the meantime, I can see that yes, this is downloading here. I could also do this in a browser if I would like, but this was very quick. Yes, it's done, and I won't use what I showed you here. So you can use this. I prefer to just right click on this, archive manager, and drag it out. Okay, we can see it's done. So I do not need this anymore. I delete this one. So we have this directory, the binary toolchain directory, and our Mario game ROM next to each other in our ESP32 directory. As you can see, the ESP32 directory here has a different name than they suggested here, so be aware if you do this like me, not using the home/ESP with the lowercase letters, then you will need to adjust some. For example, here this exports something which is in this exact directory, so if you use another one, then you will need to change this, and because I am using another directory, I will need to change this one. So now I will go to the next step, and you can see that this exact export line is the next step. You can do this every time, but that's painful, so I suggest putting it into this file, so it will automatically export this path every time you start up your shell. Now I will only just copy that one here, yes, and correct this one for my directory, and path exported. I'll skip this one, but you should do this. There's an alternative way where you can make an alias for the command. You can do this. I won't do this one either now. And there's some information to Arch Linux users. I'm using Ubuntu, so I am skipping this one also. There's an alternative step where you can compile the whole toolchain, and I won't do that. And I don't know, if you're very advanced, then you should do this, but I think just downloading the toolchain and using that is enough. We don't need to build it. So let's go to step 2, getting the ESP IDF source from the GitHub. Note that this is a recursive git cloning. First, we need to go into the directory, and yes, we are there. So I'm gonna clone this recursively here. Yes, cloning. And while this is cloning the Git recursively, I will tell you that recently I updated my version, and it went into some kind of weird error, and I didn't know what the hell it was, what was going on. And this is because I used only git pull, which pulled only one repository, and because of this recursiveness I also needed to pull all other repositories. So be aware that if you already have cloned the ESP IDF, then after a git pull, update every other recursively pulled in git repository there. Otherwise you will get some unexpected errors and you will end up using every single possible way to try and figure out what the hell is wrong. Okay, it is done now. We can see the toolchain and now the ESP IDF source code also with Mario. I can see here, yes, it's there. And we can move on to step 3, starting a project. Now I will do this one because I want to know if this is going to work or not. Let's not jump straight into deep water by trying to do the emulator at first, because if there's some glitch, then we can know it with using just a small hello world. And yes, it starts up with going into the directory which I am at now, and I will clone this template here. This one is a small ESP IDF application template. Oh, I think I didn't. Yes, I didn't include this one. It's just the name of the directory, so I won't do this again. It will be just ESP IDF template, and here we can see some files, the license, make file, so we will need to use make in order to compile it. There's a readme for this one and an SDK config, which is for the ESP IDF development framework configuration. I will talk about this later on. Let's go into main, and here is our main C, which I remember is, oh, this is too small, I think. I will open it up here. No, ESP32, yes, template, main C, yes, this has bigger letters on it, and yes, this is a Wi-Fi thing, and I don't want to have a Wi-Fi stuff here. I just want to have a Hello World program. So for the time being I will step back, and in the ESP IDF I can go here in the example directory into the get started one, and there is the Hello World. I am going to use the Hello World main.c, so the Hello World example, to just print out Hello World for me and then restart in 10 seconds. Then Hello World and restart in 10 seconds. This is all it does, and I'm gonna use this one. So see the raw material here, copy it and paste it here, save, and now my main C contains this Hello World program. Okay, let's go back and back at the point where we have this back one level. Yes, the setup guide. Go to this step where I have cloned the template, and I have cloned this template, modified the main.c, so I have a Hello World program. Now I can go on to step 4, building and flashing the application. Here I will need to go into my application directory, and because I by my mistake I did not include this in my line, I have another name for that directory, which is ESP IDF template. Very nice name. And if I am here, then I will need to export this IDF path in order for the make file to find the ESP IDF. Of course, I can do this every time I want to make something, but I suggest you put in the what was it again? Yes, the bash profile file. So it will be exported every time you need to do something, and you won't have to worry about exporting it by hand every time. And please note this one. I have another name for that, so I will change it to ESP32 ESP IDF. Yes, it is there, exported. Okay, and I can go on to make menu config, which will use I will show you make menu config. This here is a menu, a very nice menu, I like it, and this is which modifies the configuration for you. And this configuration is very, how to say, essential for you. Mostly this one. I think it's on the page also. Yes, navigate to serial flasher config and set the default serial port. This is very necessary to modify, because if you don't have your device on this place, then it will never find it. If you have it here on the USB 1, or we can go on, then you will need to change this one. I have mine here on the /dev/tty USB 0, so I will leave it here, and I won't change any other thing here, but I will go back and explain in a few words some of these. So the tool configuration, here you can set the prefix for the tool, the compiler toolchain, which is okay. This one is, I think, Arch Linux users will need to change it. Yes, be aware. I have Ubuntu Linux, so I don't need to change that one. So this is the Python interpreter. Here we can set the logging verbosity on bootloader. Yes, there are some security features here, and serial flasher config you've seen. The partition table is a very simple partition table setting for your application, and you can set it for over-the-air configuration, for example, or have a custom partition table, which will be in the NES emulator. But for now, this Hello World can use the single factory app, no over-the-air configuration. I will go back now, and there's an optimization level which can be set, debugging and release, and a component configuration which has many things here. I won't tell much more about these, just highlight these three which are in brackets, because you can enable and disable Bluetooth, enable disable Wi-Fi, and enable disable Ethernet. This will be very essential to disable here when we will try to compile and flash our NES emulator, because if you enable Wi-Fi, it will pull in lots of source code, and it will try to use more memory at runtime, and this showed me an error when I was trying to start up my emulator, because it just ran out of RAM. So for now it's okay to have or not have any of them, because we have a hello world. I will leave it just like it was, and I will go back now escape and escape, and save the configuration. Now I have set up my configuration and I can run make flash. Before that, I will see if I have attached my device, and I cannot access this one because I did not actually attach my device. And now I'm attaching it, and after that it is there, so I can make flash. It will take some time because at first it compiles everything, so I can go on and talk to you while this is compiling everything it has. Now you don't only have the main.c here, but setting up everything, you have also the ESP IDF source code. So when I am making this one here and building into this directory, then this will compile everything. You can see here the Ethernet, free RTOS, everything, just Bluetooth, yes, I found that JSON. So when you make your project, it will make everything, and now it is trying to connect to my device, and it is waiting for me to press now I don't know what's exactly happening because I have another machine where it just tells me connecting and it immediately uploads everything. On this machine, up to now, I had to push the flash button on the SparkFun ESP thing, which is right here. So after the make flash and I saw this connecting, I had to press this button in order to make it happen. Otherwise I got an error. Now I see they've added some underlines here. I don't know what exactly this does, but giving more time for disconnecting, I think I don't have to press the button on this machine either anymore. So all I need to do is make flash and eventually it will happen. I think if I do well, let's make a test. Make flash. It says connecting, pressing the button. Yes, if I press the button, then it will take less time, but I think I don't have to press that button. I don't know the exact thing which happens at the SparkFun thing, but I can show you the schematics of it, and this is because I wanted to show this part, the automatic reset part. This is a very handy tool to have on your board, and make sure, if you're a starter or just want to fiddle with stuff and not to worry about many things, that you have this auto reset mechanism built onto your board. I think this SparkFun thing has it here. Yes, I can barely see it here. Let's go back to the schematics. So it is using the chip power up and the GPIO 0, which is the flash GPIO. So it drives them via DTR and RTS lines of the FTDI chip. So it is automatically doing us one reset and flash mechanism. So when I do this make flash, it first resets my board into a downloading mode, then it tries to connect there. They synchronize themselves somehow. I don't know why I have to press the flash button, but anyway, they synchronize themselves and it can upload the whole flash. After uploading, it is doing a reset, and that reset will be without the pressing of this GPIO 0, and it will start up the Hello World program. You can look into this more if you want to. If you are a basic user, then please make sure your board has this on it, because otherwise you will need to do this manually, and that is painful. Okay, where I want it to go? Yes, here. We can't see anything, so I will use CuteCom. Very cute, nice little software. I like it. I will connect to the device via serial, and I'm opening it now. I should see it. Yes, it is telling me restarting in 4, 3, 2, 1, 0. It restarts, and okay, I will close it. There is it telling me hello world. All this stuff you see above that one is the resetting. So it tells me that it was a CPU reset and it is booting in fast flash boot. So it boots up from the flash, shows some information about itself and starts up the CPU. Then my Hello World program starts up. Let's see what happens if I restart it by holding the flash button. So I will hold down the flash here, this button, then briefly press the reset button, and let's see what we will see in our CuteCom. I will clear this, open the device. It is opaque. So restarting in 7, 6. Okay, and now I'm pressing reset, and this restarted in download boot mode. This is what happens when I tell it make flash, and it is waiting for download. It is waiting for the uploader program to upload the firmware so it can download it onto the flash. Now I'm just pressing the reset without holding the GPIO 0, which is the flash, and it will reset into my program. Okay, maybe this was an overkill, but I think you understand now what happens exactly here when I tell it make flash. This whole thing here. Okay, we have an easy Hello World program, and now I will tell you how to upload actually the emulator. The emulator itself was done by Espressif, so I will go back here and go up Espressif in the GitHub, and somewhere here we will see that there is, okay, yes, here is the ESP32 NES emulator, a proof of concept NES emulator for the ESP32 made by SpriteTM. Very cool. This is very cool, man. And this is acting as a simple ESP IDF project, so I can clone it here in this directory beside the ESP IDF and do the make menu config and make flash like I did in the template. Also, it has a brief information about the display. You will need this one. So this okay, I won't pronounce it, you can see it obviously, is this display. And here you can see the pins for the display and which GPIOs you should connect these to. On a SparkFun ESP32 thing, it looks like this. Well, something like this. And if you want to use a controller, then you will need a PlayStation 1 or 2 controller and connect those pins to these GPIOs, but well, I have actually PlayStation 2 controllers, but I can't connect these to the pins. I would need to take apart my controller. I don't want to do what SpriteTM did. That's why I only have here an LCD which was just showing me the intro screen of the Super Mario. I didn't want anything more than that. It was just a proof of concept that it can work. If you want to have the controller, then go ahead, you can make it. It's just right here. Now I will clone this project, copy, it says copied. I will go back here and git clone. Yes, please clone this one. Okay, now I have also the emulator directory, and I will go into that one, and as we can see, this looks a bit like the template, except that it has a flash ROM shell script which is for uploading ROMs for the emulator. Of course it needs ROMs to run something, so this uploads it to the right place in the flash. It's very brief. I will show it to you. It also has the make file, and this is the partitions CSV, which tells the ESP IDF where are the partitions, because it needs one partition to store the ROM in, and have another one which has the binaries which are running. Okay, there's a readme, and here we can see the config, and in the components and main there are the sources, of course. Now let's do the make menu config as we did with our other configuration, and go into the serial flasher config, and as you can see, the original configuration here has USB 1. Okay, my device is on 0, so I need to modify this one. I don't know why it is on this baud rate. I will select this one. I don't know why I do this. Maybe this is better. Well, it's better because it's faster. I don't know. Either one is okay. Now let's head back and see that this is now set to custom partition table, and here you see that the partitions CSV is set as the custom partition file, and here it says where is the application itself in the flash. Okay, I need to do only one more thing. Disable this, because if you don't do this, then it won't run. Well, it will run, but it will tell you that it's out of RAM and restart. Out of RAM, restart. Out of RAM, restart. Out of RAM, restart. So that's not good for us. Disabled it. Escape. Escape. Save. Now I have this set up correctly, and make flash. I think this will fail, but before that I will tell you why this takes so long, because as I told you in the template, it built everything. Now here, if I go in, we can see that it has its own build directory. So this one here also builds everything, all the ESP IDF software development framework, so we will need to wait for that to compile. But if we modify just the source for our project, then it won't compile everything. And now we stopped because there's an error, and I know about this one. This VSPI CLK out MUX IDX, you don't need to know what this is. You only need to know that this MUX is not there anymore in the ESP IDF. So we will need to modify this SPI LCD in the components / NoFrendo ESP32 / SPI LCD.c. Now let's check that one. So we have components. This is the NoFrendo emulator, which was ported to the ESP32, and this one contains components for the port itself. You can modify this one if you want, if you need to have another type of controller, and this one has the LCD, and this is, well, video, audio. I don't know about the audio because as far as I know, Sprite TM disabled everything that's connected to audio, so it may have only the video in itself and stubs for the audio. I will need to change this one, so let's move this to our editor. And I did something wrong. Okay, open just like this. No, I don't want to change. Okay, this here is the emulator, components, NoFrendo ESP, and the SPI LCD.c. Now, which line was it? Okay, well, it's down in the code. I will just search for underscore MUX underscore, and there are things which need this, but there is one VSPI connected thing which doesn't need it, so I will delete this MUX out of there, and as you can see, they are really nicely looking this way. So I think that was the reason, because this way they all are kind of synchronized looking or something like that. And now let's make flash it again. Okay, and it goes tries to connect. I won't press the flash button. Let's check it out, what it does. Hopefully it will automatically do the flashing for me. It's very interesting. Why does it work immediately on my other machine, and why does it not work here? Failed. Okay, so I will press the button then. Now. Yes. I don't know, maybe something on very low level, how to say, it's low level hardware stuff which I don't know of. At least it's working. Okay, it says hard resetting, and now we have the emulator working on our module. So open the device and let's see what it shows us. Nothing. That's not good. I will reset the device. Oh, I know. This is my bad. There was the ROM already uploaded to this SparkFun ESP32 thing in its flash. So what you should see after make flash, that it is going in a reset loop because it can't find any ROM in its flash, and then it resets, can't find the ROM, reset, can't find the ROM, reset. But because I've already uploaded the Mario there, it is working. Okay, I don't know how to break that one. Maybe upload something with random data there, but you will see that for you it won't work at first, and you will need to do what I will do now. Use the flash ROM shell script. So let's see. We have Mario NES here. I will copy it into the emulator directory, and I will open here the flash ROM shell script. As you can see, it is really short. It says add path IDF. Yes, it needs the IDF path, and it starts something there. Then it just uses the ESP tool to upload onto the flash the first argument which was given to this script. And as you can see here, I need to change it to 0, so this will upload to my ESP module, and I am adding here just one line which was used because I want to be really sure that it works. So copy this please and paste it. Okay, this thing I've pasted here just exports the IDF path, so I'm sure that every time it will use this. It's just for my own relief. And if I use flash ROM, first I will check the Mario. Yes, it's right there. So I will use the flash ROM shell script to upload Mario NES. This is a ROM, and it will try to connect. I press the flash button and it uploaded the Mario there, and now it works. Let's try what if I, for example, upload the README. Upload the README, please. Haha. Okay, now I have uploaded something which is not acceptable for the emulator. Let's see how it reacts. Now I open the device and yes, it is in a reset loop. Let's close the device and have a closer look at what it exactly does. So there was a CPU reset. It starts from flash and loads everything. There are some initial I'm not I don't know what all of these mean, but this is when the CPU starts. So after that, NoFrendo starts, and it did a configuration and I stopped it just in between, so I will need to go up a bit where we see, yes, more. So the emulator starts up. It starts up SPI and sets up 4 GPIOs. These are for the controller, and it says no PlayStation controller detected. You will not be able to control the game. Yes, I know that. And video initialization is done. System type yet unknown. Playing NoFrendo NES intro. Initialized. ROM at this point. It reads in the first 4 bytes of the ROM image, and it says it is not a valid ROM image, of course. ROM freed, not loaded, NoFrendo died, VTF. And then there's a very exciting register dump, a backtrace, and it reboots. And it does this all the time. So if I open the device, it's still restarting. My poor thing. and now I will upload the Mario onto it. Press the flash button, yes, and now it has the Mario. Okay, open device. I can't see anything. I will reset, and now I will tell you what happened. The power on reset button was pressed, and there is a flash boot. There are some stuff. Processor started. NoFrendo emulator started. SPI configured. The GPIOs for the controller are set, but no controller detected. Okay, video initialization done. System type unknown, playing intro. Initialized. It is now checking for the ROM, and it sees these bytes. This is, I think, big M, big E, big S, and then enter. And that is the correct way to start NES ROM. And now the ROM loaded, created memory mapper, setting it up, resetting, NES powered on, and timer install frequency is 60, whatever it means, and now it is running. We can't see anything, but if I would attach an LCD at the right GPIOs, we could see the thing which I've already shown you in my previous video. So this was it. I hope it helped, and if you want, I could try to do this on a Windows machine, if my wife allows me to do it, because there are things which might not work there, like this flash ROM shell script, obviously not working on a Windows machine, but you can have a make file. So if I open the make file, it just has this project name and include make project. So if I put here something that please flash my ROM, and then something there, then it will do the flashing by typing make please flash my ROM, and this was actually done by somebody. You can check it out here in GitHub, in network graphs. So someone here made a makefile modification. I don't know who was that. Yes, add options to makefile for serial monitor and ROM upload. So this here shows you how to add something to your makefile to let it upload the ROM for you. It is done like this, so it will upload the ROM if it's ending with .NES, so it will look like make mario.nes, and it will upload automatically. So yes, there are things to this which can be also shown if there are any requests for it, and for now it was all I wanted to say. Hope it was helpful, and have a nice day. Goodbye.